Hello again, everybody. Today we are going to work on section 5 of the Circles and Systems unit, which is actually where we get into the systems. Mac is here helping me again today, so if you see her on camera, I apologize. So we are going to talk about systems of equations and inequalities. So everything we've been doing so far this chapter has sort of worked up to this point. We're going to see a lot of the different constructs that we've used this chapter when we talk about systems of equations. You've done systems of equations before. You did it last year in Algebra 1, but you kept it to systems of linear equations and systems of linear inequalities. Today, I am going to be able to give you any kind of equation and inequality that we've looked at so far, and then you'll be able to show the system that is created by those. So one thing we're going to talk about today is one way to solve systems algebraically when we have circles, and the rest of the things we're going to talk about are solving systems graphically. So if we have a system with circles in the equations, one of the things that we're going to want to do is we are going to want to only use the substitution method. The elimination method is not going to work here because we don't have two equations that are in the same form. So we're going to use the substitution method, and we're going to use it pretty much the same way that we used the substitution method in the last chapter. And that's going to be that we're going to turn one of these into a y equals or an x equals equation. We want to solve again for the loneliest variable. However, we're going to have to solve a quadratic equation. So we're going to bring back in some of our parabola strategies, our quadratic equation solving strategies, in order to do these. And then the other thing that we want to talk about is that there could be multiple intersection points. Because if we're talking about a line that's intersecting a circle, it's possible that we could have no intersection points, right? A line and a circle that don't touch. We could have one intersection point, that would be if we had a tangent line, or we could have two intersection points. And so all of those possibilities need to be considered when we're solving systems that involve circles. And so we are going to look at this first one. We've got 2x minus y equals 2, and there is a typo in the next problem. It should be x squared plus y squared equals 25, so that it's actually the equation of a circle. So make sure you change that in your notes. So let's solve for the loneliest variable, so-called loneliest variable up here. That would be maybe our y. So let's solve for y. We'll subtract 2x from both sides, and we've got negative y equals negative 2x plus 2. We want positive y, though, so we're going to go ahead and multiply that by negative 1. And we've got y equals 2x minus 2. So there's our substitution quantity. We can take 2x minus 2, and we can substitute it where we see the y in here. So that's what we're going to do. We're going to say x squared plus, parentheses, 2x minus 2 squared equals 25. So we're substituting this quantity for y. And we see that we have a binomial that is getting squared. We remember that that means we're going to FOIL this to multiply. We're not just going to square both of them. We remember this as 2x minus 2 times 2x minus 2. That's what the squared means there. Equals 25. And we're going to FOIL. So we've got x squared plus, first, 2x times 2x is 4x squared. Outside, 2x times negative 2 is minus 4x. Inside, negative 2 times 2x is minus 4x. And then last, negative 2 times negative 2 is positive 4 equals 25. And so let's simplify this down. We've got x squared plus 4x squared, so actually 5x squared plus negative 8x plus 4 equals 25. And so we've got this quadratic equation to solve, and I think that the best way to do this one, because there's lots of different kinds of numbers, nothing's dividable, we're going to use the quadratic formula, just because we know it's going to work. So let's subtract 25 from both sides, because in order to use the quadratic formula, we need it to be equal to 0. So 5x squared minus 8x, 4 minus 25 is going to give us negative 21 equals 0. So 5x squared minus 8x minus 21 equals 0. And we're going to use the quadratic formula there. So we're going to say that that is going to be negative b, so negative 8 plus or minus the square root of negative 8 squared minus 4 times 5, our a value, times negative 21, our c value, all over 2 times 5. So we're going to do this. We're going to simplify all that down. So negative 8 is just 8 plus or minus the square root of 64, and then 4 times 5 times 21, that's going to be plus 420 over 10. So then we've got 8 plus or minus the square root of 484 over 10. And the square root of 484 is 22. Hi, Mac. How are you doing today? So we've got 8 plus or minus 22 over 10. Of course, we're going to split that into two possibilities. We could have 8 plus 22 over 10 or 8 minus 22 over 10. Either of those is going to give us a valuable and viable solution. This is 30 divided by 10, which is 3. So x equals 3. This is negative 14 divided by 10, which is negative 1.4. So this is a system with two intersection points. This line is going to intersect the circle in two places. It's going to intersect at x equals 3 and at x equals negative 1.4. However, this is still a system of equations, so we need to continue here because we need to find the y values of each of these coordinate points. Lucky for us, that's easy with substitution. We just put it back into the equation. So we take this and make it y equals 2x minus 2. So y equals 2 times 3 minus 2. That's our first point because we're substituting the x value of 3. So that's going to be y equals 4. So we have a coordinate point solution of 3, 4. And then we've got to do the same thing with the other coordinate point that we found, the other intersection point of the line in the circle. So we've got y equals 2 times negative 1.4 minus 2. And that's going to be y equals negative 2.8 minus 2, negative 4.8. So we've got x value of negative 1.4, y value of negative 4.8. So that is the other intersection point. Those are the two solutions of this system of equations. Let's do another one real quick just to make sure that we've got it all. So over here we've got x squared plus y squared equals 40 and x plus y equals 4. Solve for the loneliest variable, and of course that's going to be in our line equation and not in our circle equation. So we will subtract y from each side. You could subtract x as well. So I've got x equals 4 minus y. I'm going to substitute 4 minus y wherever I see an x in the top equation. So I'm going to say that is 4 minus y squared. Hi, Mac. 4 minus y squared, and then plus y squared equals 40. So we've got to FOIL this first part. So that's like 4 minus y times 4 minus y plus y squared equals 40. That gives us 16 minus 4y minus 4y plus y squared equals 40. And then we will simplify all of this back down. So we've got 2y squared minus 8y plus 16 equals 40. And again, since it's a quadratic equation, we want to move everything to the left. So we'll subtract 40 from each side. And we get 2y squared minus 8y. Let's see, 16 minus 40 is negative 24 equals 0. Hey, look, what I see here is that everything could be divided by 2. Maybe we don't have to use the quadratic formula here. Maybe there's an easier way to do it. If I divide both sides by 2, I get y squared minus 4y minus 12 equals 0. And if I think about that, that's going to be something that I can actually factor. We've got to look for, because we have a y squared at the beginning, we can use the shortcut factoring method where we look for two numbers that add to -4 and multiply to -12. That's going to be 2 and 6, and it's going to be a -6 and a +2 in order to add to -4. So I'm going to say that that is y minus 6 and y plus 2 equals 0. And of course, you remember that when factoring, these are not our solutions. This is just our factored form. We need to flip the sign. We can say that this is y equals 6 and y equals -2. So these are the two y values of the solution of the system. Again, the system will have two solutions. So we'll come back up here and we will plug in those y values. I have this equation of x equals 4 minus y, so I can use that. So I've got x equals 4 minus 6. That's going to be x equals -2. So we have a solution of 6 comma -2. And we have a solution here. We've got x equals 4 minus -2. And that's going to be then x equals 6